Okay, so this vision statement goes back a little ways, but it hits some of the same things. Like we want containers to be a first-class user experience, but we've kind of gone a little bit further. You'll notice that the title that I used was containers everywhere, and I'm going to sort of explain what I mean by that. But we want to also make sure that containers are supported in all the right ways. But really the idea is that anything that a user does and interacts on the system is running inside a container, right? So today they can do that, but it's explicit and they have to kind of intentionally do it. The idea is to make this just the way things are running under the hood. So, and this doesn't mean that all our users have to suddenly become container experts. So we want to implement this in a way where they can keep doing things the way they're used to today, so the transition is easy, but because they'll have containers underneath it, there's flexibility that gets unlocked, and those that are ready can take advantage of that over time. So you'll see some of the same points here that Alberto made in his, so one is, by adopting containers everywhere, it'll improve portability, reproducibility, and customization. The other that he alluded to is decoupling our user environments from the system, the underlying system. And that's both to give, this additional flexibility, but another reason for it that's at least important at NERSC, it also gets to sort of what CJ was talking about earlier today, was our system staff are oftentimes a bottleneck in like how fast we can get some things done. And so if we can decouple these things, then we can have other parts of the organization handle those pieces, right? So we have a group that does programming environments now, and so they could really own the user environment, for example. It provides levels of isolation and some other kind of flexibility, and like Alberto was saying, then we can start to develop building blocks as well. So it has both technical benefits, but sort of organizational benefits as well. Another is like why, if it's going to be transparent and the users aren't going to see a difference, then why would you bother? But again, it gets back to some of these same arguments. It allows us for the user environment to move at a different pace than the rest of the system. So they don't have to move in lockstep, was one benefit, but it also means that users can adopt a new version, for example, maybe while others are still staying back. And then it also gives us a way to, once we have this in place, then there's an easier way that we can roll out updates. We can sort of do A/B testing in a way that you really can't do in a system where it's all depending on sort of what state it's booted into. And this was done for internal purposes, so if you see CSG, that's the computational systems group. So that's the system administrator. So you'll see references to that. It's kind of scattered. This was really a kind of an internal presentation to convince everybody that this was a great idea. Okay, so what we want to be able to do is manage these user environments via containers, but it needs to be transparent. It needs to be gives users flexibility, and we can't compromise on things like security or performance or scalability. And for all the arguments that I've already made. So kind of the starting points that we have is, again, this is sort of internal audience to NERSC, but we've got shifter and podman HPC that kind of prove as, provide demonstration that we can do that last bullet, that we know how to do things securely, do them performant and scale. So that's a good foundation to kind of build on, even if it's not those tools precisely, just the experience we've gained from developing those and supporting them will be important. And the other is, you look out on the landscape, there's a lot of tools and pieces being developed that we think are synergistic, and we might be able to use those, but in many cases we'll look at it and there'll be slight gaps in those, and so we have to kind of figure those out and work through them. The biggest thing is trying to get kind of all of it integrated together. So I'm going to go through one kind of very canonical, simple use case. Like, let's just think about the user that logs onto the system. They need to compile a code. They want to submit it. They want to monitor that job and kind of see the results. So like really the most basic of developer workflows that we need to do on an HPC system. I'm going to skip back. I'll maybe come back to this one a little bit later. So, so what do we need to have in place to support that? One is we need at least one, but ideally multiple images that contain all the tools in terms of like the programming environment, compilers, libraries, et cetera. We need some mechanism to kind of define these environments. A lot of like what Alberto was showing with his TOML file, you know, it's those exact same things, like what images, what things need to be mounted and available, et cetera. We need mechanisms for the users to be able to kind of control what environment they're going to land in when they log in and they submit jobs. We need a mechanism to place them in that environment, so we need some hooks in the kind of the SSH stream, for example, to be able to do this. You know, they need to be able to compile applications. If you've done number one right, then that should really address that. They need to be able to interact with the scheduler, so you need to make sure those pieces are kind of functional. And very critically, we need to make sure that the development environment, when they go run the job, it needs to be in that same one. So we need it to be integrated with Slurm in the right way. It's similar to what Alberto was showing in his. And then, you know, for performance reasons, we need to make sure that we have native access to all the key resources. And then, you know, we need all of these things at once. So the checkboxes indicate sort of like status of where we are internally at trying to prototype some of these things. So the green ones are ones where we've got sort of something we can point to that exists that's functional. The yellow ones where we've got maybe there's some things we're exploring. It looks promising, but we haven't really quite demonstrated. And, you know, the all at once is we definitely haven't done. Okay, now I'm going to talk a little bit about the user environments that we were kind of thinking, because one debate we're having is like, what should this look like from the user standpoint? So we had a kind of a range of options that we were sort of thinking about. So we might start with just, and I'll go through more details in these in just a bit, but one would be a classic one that would look much like what they see today. So for the users that are used to like using module load and all that stuff, like we could retain that, and so they wouldn't have to change their behavior. But over time, we might do things like introduce kind of fixed stacks, and then eventually allow more customization and flexibility where users could define their own. And you know, these are not, it's not like we can only do one of those. We could support all of these potentially on the system at the same time. And I think I'll skip over the rest. Okay, so the classic would be, oh, and I had a demo. I think we had just like a kind of a mocked up container image that would show this. I'm not going to show that today. But this one would, again, replicate sort of the existing environment that the users are already used to. And then the stacks would be where maybe we've selectively chosen, like, here's a compiler, here's a set of libraries. You know, we've defined that, and then those can be version things that we can release and manage, you know, over time. So, you know, and they could be validated with with things like reframe test. Were you good on time? No. Okay. Another one that just, you know, a benefit here is like one challenge we have today is we might do updates, you know, on the system, and it drifts from the time that the users built, oh, thank you, from the time that they've like compiled and built their code, submitted it, and then, you know, so this, having this in place kind of protects against that scenario. And then lastly would be where we start to allow users more ability to customize things. So that may be, you know, what packages and tools are in it. And we've thought about different models for how we might allow users to do this. So one would be, have people used Binder Hub before? Okay, it's used in Jupyter. So with that one, you can give it, like you pointed at a repo, and it can have like a requirements.txt file or a couple of other kind of standard things, and it'll just build an image kind of almost on the fly from that manifest, so to speak. So, you know, one model would be something like that. Another would be, you know, sort of user interfaces. So this is kind of mocking up some different ways that we might allow users to define it. One would be they could do like an image designer through a, you know, a simple web UI, and it would generate the Dockerfile form and build the image for them, for example. Or another would be some, you know, manifest type file kind of format. So we're exploring, I think we want to try different approaches, try them out with users and get feedback. But this is also something where once we start to build these environments, I think they could be shared across facilities, much more easily. So I could imagine starting to have standard ones that, people could adopt and run at different places. And then, kind of moving past that very simple workflow that I was talking about, eventually we need to make sure that all the things that users are accustomed to seeing have to be addressed. So we need to make sure debuggers and performance tools and stuff like that work in this framework. Some of the things I talked about with being able to compose images. Iris is our system management, like our account management system. So you'd want users to be able to go in and sort of have ways where they could pick what environments they wanted to land in. There's a few kind of technical ones here that I maybe will just touch on. And one is right now we use user namespaces for at least the Podman HPC. And one thing that's really bad about it is, if anybody's used this, I didn't realize this limitation started using it, is if you go and look at file systems that aren't owned by you, they will all be nobody, right? And so if you're just using it, containers to run your application, you probably don't care about that. But if this is how you're interacting in the system, like, this is really bad, because now you might go to a shared directory and you're like, I don't know who created that. So, there's some kind of dumb limitations like that we need to figure out. So, just ways to make it feel as native and transparent, like, especially for the traditional users. So these are some of the challenges that we've got to overcome. Another one related to the user namespaces, there's these kind of usability issues that we've got to deal with. But another is kind of the kind of reoccurring security concern. So if we're really dependent on user namespaces, and then yet another kernel bug comes around and they say, well, the way to avoid this is turn off user namespaces, suddenly our system would be dead in the water. So we need mitigations for that. Yeah, and I'll leave the rest off. Okay, and the other thing I was going to say is, is building up the expertise within the staff. There's a group of there's a large group within the nurse staff that are comfortable with containers. We give tutorials on it. We help people with it, and then there's a lot that aren't. And if we're going to move towards this model, then at least the staff need to be comfortable with it. And so that's another thing and that was the reason for the graphic, is because some of them, people are sort of scared by it. And so when we presented this internally, we wanted to make people understand that it didn't have to be scary. Okay, that's it. Thanks.